Hello students, in this session let us learn to work out numericals that are related to dipole moment. Generally this is one area where students find difficult. We know what is a dipole and how electronegativity difference brings ionic character into a covalent bond. To calculate the percentage of ionic character in a covalent bond, the formula is, so percentage of ionic character is given by a formula mu observed by mu calculated into 100. What is this mu observed? It is an experimental data which will be always given in the problem. It will be always from problem. This data will be surely furnished in the problem. Now this is what we need to find out. We need to calculate mu theoretical value. Okay. So to calculate this mu theoretical value, we need to have Q into D. Okay, the formula to find out mu calculation, mu theoretical value is Q into D. D is nothing but bond length. It is nothing but bond length. This will also be given in the problem. And this Q can be expressed in two different units. One is in terms of coulombs and another is in terms of electrostatic units. In terms of Q, in terms of coulombs, it is 1.602 into 10 to the power minus 19 coulombs, and in terms of electrostatic units, it is 4.8 into 10 to the power minus 10 ESU. Okay students, right. Now this Q doesn't have any plus charge or minus charge. In other words, it is nothing but the magnitude of one charge. Okay, and one more thing we need to know, that it is the conversion factor. See, generally dipole moment will be expressed in terms of d by. So 1 d by d is nothing but d by 1 d by is nothing but 1 into 10 to the power minus 18 electrostatic units centimeter, and that is equal to 3.33 into 10 to the power minus 30 coulomb meter. So this conversion factor, students, you need to remember. Okay. So the percentage of ionic character can be expressed in terms of mu absorbed divided by Q into D. We know that what is Q? Q is nothing but the value of one unit charge. We take only the magnitude, not the sign, and D is nothing but the bond length of the given molecule. And mu observed will be always provided in the problem. Okay. Now, if mu observed is given in terms of coulomb meter, then I want you to choose the Q value in terms of coulombs. That is 1.602 into 10 to the power minus 19 coulombs. If it is given in terms of ESU, then I want you to choose the value of Q in terms of ESU, that is 4.8 into 10 to the power minus 10 ESU. Okay. So students, we are going to work out some problems. I want you to pause the video, collect the data given in the problem, and try to work out on your own and check the answer. Now, the problem goes like this. Dipole moment of KCl is 3.336 in 10 to the power minus 29 coulomb meter, which indicates that it is highly polar. The interatomic distance between potassium ion and chloride ion is 2.6 into 10 to the power minus 10 meter. The percentage of KCl is, so we need to find out the percentage of potassium chloride, and KCl has been given. This dipole moment of KCl is given, and bond length has been given. So we know that percentage of ionic character is given by the formula mu observed by Q into D, right? Since the observed mu value is given in terms of coulomb and meter, I need to take the value of Q in terms of coulombs. So it is 3.336 into 10 to the power minus 29 coulomb meter divided by 1.602 into 10 to the power minus 19 coulombs into 2.6 into 10 to the power minus 10 meter, and this should be multiplied with 100 so as to get the percentage. So you can see, students, 10 to the power minus 19 and 10 to the power minus 10. This amounts to 10 to the power minus 20. So everything will get cancelled, these terms. Okay. So it is 3.336 divided by 1.602 into 2.6 into 100. Okay. And if you work out this, you will get 80.09%. So the option B is the right answer. Second problem. if bond length of HCl is 1.275 angstrom and ionic moment is 1.03 dBi, the percentage of ionic character in HCl bond is, so the four options are given. We know that percentage of ionic character is given by the formula mu observed by Q into D, okay, into 100 of course. So since the mu observed is given in terms of dBi, here it is given in terms of dBi, we are going to convert it into coulomb meter. Fine. So 1.03 dBi, I'm going to convert it into coulomb meter. So I need to multiply with 3.33 into 10 to the power minus 30 coulomb meter. Right. This is the conversion factor. And since the numerator is in terms of coulomb, I need to choose the value of Q in terms of coulombs. That's why 1.602 into 10 to the power minus 19 coulombs, and D should be expressed in terms of meters. So 1.275 into 10 to the power minus 10 meter, right? So if you cancel them out, you will get 1.03 into 3.33 into 10 to the power minus 1 divided by 1.602 into 1.275, because this one 10 to the power minus 19, 10 to the power minus 29, this will come to 10 to the power minus 29, so they will get cancelled, and that's why you get 10 to the power minus 1, and of course to get in terms of percentage you need to multiply with 100. So when you work out this, you will get 16.78 percentage. So the option C is very closer to this. So option C is the right answer. The dipole moment of lithium hydride is 5.898 into 10 to the power minus 18 ESU centimeter, and the intra-atomic distance between lithium and hydrogen is in the molecule is 1.596 angstrom. So this is going to be the bond length, and this is the observed mu value. So mu value has been given in terms of electrostatic unit centimeter. Okay, so the percentage of ionic character can be expressed in terms of mu observed by Q into D into 100, of course. So this is nothing but 5.898 into 10 to the power minus 18 ESU centimeter divided by 4.8 into 10 to the power minus 10 ESU into 1.596 into 10 to the power minus 8 centimeter. 0.596 into 10 to the power minus 8 centimeter. Then only both things will get cancelled. So 10 to the power minus 10 and 10 to the power minus 8 in the denominator will add up to 10 to the power minus 18. So I can cancel these terms including the units, ESU, everything. So I can simplify like 5.898 divided by 4.8 into 1.596. When you work out, you will get 76.99 percentage. So option A is the closest one. So option A is the right answer. So the fourth problem is the dipole moment of HBr is 0.78 dBi and the bond length is 1.41 angstrom. If electronic charge is 4.8 into 10 to the power minus 10 ESU, then the fractional charges. We need to find out fractional charge. The formula to find out fractional charge is nothing but the ratio between Q and E. Now Q is nothing but the magnitude of unit charge, and this magnitude of unit charge should be derived, it should be obtained from the given mu value. Okay, so I need to find out the value of Q in my first step. So I know that mu observed is nothing but Q into D, which means mu observed divided by D will give me my Q value. Now mu observed is nothing but 0.78, and I require it in terms of ESU because the electronic charge is given in terms of ESU. So that's why I'm going to convert it into in terms of ESU, right? So it will be I know that 1 dBi is equal to 1 into 10 to the power minus 18 ESU Cm, right? I know this, so I'm going to multiply this with minus 18 ESU centimeter, and since I have centimeter in the numerator, my bond length should be expressed in terms of centimeter. That's why 1.41 into 10 to the power minus 8 centimeter. So this centimeter and centimeter will get cancelled, and this is the value of Q, and if I work out, I'll get 0.55 into 10 to the power minus 10 ESU. This is the value of Q. Now the fractional charge. So fractional charge is nothing but Q by E. So Q, we know that it is 0.55 into 10 to the power minus 10 ESU, and denominator E value is the standard value 4.8 into 10 to the power minus 10 ESU. So if I work out that, they'll get cancelled and I'll get a value which is very closer to 0.11, which means option D is the right answer. Fifth problem. The electronegativities of hydrogen and fluorine are 2.1 and 4.0 respectively. Then the percentage of covalent character is. So here the electronegativities of hydrogen and fluorine are given. So we need to find out what is the ionic character of this bond. Okay, since I have been given the electronegativity values of hydrogen and fluorine, and I don't have any mu value, that is dipole moment value hasn't been given and bond length hasn't been given. So in this case I need to use another formula called Haney-Smith equation. Haney and Smith equation, right? This equation goes like this. It is the percentage of ionic character is 16 into electronegativity difference between A and B plus 3.5 into electronegativity difference square. Okay, now if I substitute these values, 16 into 4.0 minus 2.1 plus 3.5 into 4.0 minus 2.1 whole square, I'll get 16 into 1.9 plus 3.5 into 1.9 whole square, right? Now if I simplify this, I'll get a 30.4 plus 12.635, which is nothing but 43.036. So this is nothing but the percentage of ionic character, but I need to find out what is the covalent character. So I know that percentage of covalent character is 100 minus ionic character, right? 100 minus ionic character. So which means 100 minus 43 will give me 57%. So option C is the right answer. Thank you guys. Thank you for visiting this channel. Thank you. Happy learning.